Students, today let us see nanomaterial CVD preparation method. Very important method in the exam point of view. Chemical vapor deposition is a very oldest technique. Okay, first method to find out the preparation of nanomaterial. Okay, this technique involves decomposition of metal organic compound at high temperature and reduced atmospheric pressure. Okay, at 720 degrees Celsius, the oven is kept. Okay, and into this we have quartz board where we have kept the sample. Okay, and this vaporizes, carbon vaporizes and then deposits as nano material. So here the gas to vaporize heat is provided with burning of acetylene and nitrogen gas. So to make it inert, so nitrogen gas and acetylene gas are given into the quartz board. Okay, so what happens at the temperature of 720 degrees Celsius and at the given pressure, so they vaporizes and they start condensing out, and the condensing carbon is deposited on the silica metallic particle, okay, with the presence of catalyst as nickel and cobalt. Okay, the reactor consists of quartz tubes surrounded by an oven. The substrate like silica mica quartz coated with a layer of metal nanoparticle like nickel cobalt is taken, so they act as the role of catalyst, right? The substrate is heated with a precursor carbon source acetylene, ethylene, methane. So acetylene is taken generally, a process gas like nitrogen. Okay, at 720 degree at high temperature the hydrocarbon are broken and produce pure carbon atom. The carbon diffuses towards the substrate and binds on the surface of the catalyst. Okay, so this is the deposition. They vaporize, okay, and they get condensed and deposit at the surface, right? Nano-sized particle of metal and ceramics can also be obtained using this method in good amount. So this can prepare rate of preparation of uh, carbon nanotube CNT is very high here. Okay, so types of CVD, we have different types of CVD. Thermal CVD, which works at high temperature, okay, and that has of different categories. We have high temperature CVD with low temperature thermal CVD, okay, and we have atmospheric pressure CVD, low pressure CVD, cold wall CVD, hot walled thermal CVD, closed thermal CVD, open thermal CVD. Lot of research has been carried out with chemical vapor deposition. So chemical vapor deposition, it's a various kinds are there. Then we have plasma CVD. In this process, the chemical reaction is activated by the plasma at a temperature between 300 degree to 700 degrees Celsius. Then we have laser CVD. In this process, the reaction is activated as a result of thermal energy from laser. Okay, heat energy we get it from laser that vaporizes the substance and that is allowed to condense. Okay, it is also called as pyrolysis process. Then photo CVD. In this process, so we chemical reaction is activated by the action of photons from UV radiation, which breaks the chemical bond in the reacting substance. It occurs at room temperature. Advantages: lower temperature range, relatively high purity CNT we get. This method can be produced both multi-walled NTs and single-walled NTs. That is, the CVD is most useful in CNT preparation. Okay, mass production can be done in industry. Thank you, students.